Now the examples what I am going to discuss today are different from the examples what we have studied under normal distribution in the earlier classes. These examples what we are going to study, we need to find the mean and the standard deviation when certain conditions are given. Also, the normal value of some particular point will also be given. In case it is not given, then you will have to use the normal table. And the question is, in a normal distribution, 31% of items are under 45 and 8% of items are over 64. Find the mean and the standard deviation. So as usual, we'll assume let mu and sigma be the mean and the standard deviation of the distribution. Here the given condition is 31%, that is a probability of items are under 45. That is, if I assume x to be the random variable, x less than 45 is 31%, and it's given that 8% of items are over. Over means it is more. So we have P of x greater than 64, P of x greater than 64 is 8%, that is equal to 0.08. Now we'll use the standard normal variate z is equal to x minus mu upon sigma, where the first x value is 45. So replace x by 45. So we have z is equal to 45 minus mu upon sigma is equal to z1. We'll assume for x is equal to 45, z is equal to z1, and for x is equal to 64, we'll assume z is equal to z2. So I have two equations. Z is equal to 45 minus mu upon sigma is equal to z1, and z is equal to 64 minus mu upon sigma is equal to z2. The given condition, now x is replaced by z, and for 45 it is z1. So P of z less than z1 is 0.31, and x is again replaced by z, and 64 is replaced by z2. So P of z greater than z2 is 0.08. So as discussed in the earlier examples, if I consider the point this as z1, this will be the area under consideration, and if I consider this point as z2, greater than will be this region. So I'll have 0.5. From 0 to this will be half, plus phi of z1 is equal to 0.31, and this will be this region, it is half, minus this region, that will be minus phi of z2 is equal to 0.08. From after simplification, phi of z1 is equal to minus 0.19 and phi of z2 is equal to 0.42. So from the given earlier condition in the example, it has given that a of 0.5 is equal to 0.1915 and a of 1.4 is equal to 0.42. So comparing these two equations, I conclude z1 is equal to minus 0.5. Remember, minus 0.1915 or 0.1915 is both same because normal distribution is symmetric. Similarly, z2 is equal to 1.4. So once we have got the z1 and z2 value, substituting them in the earlier equation, that is 45 minus mu upon sigma is equal to minus 0.5 and 64 minus mu upon sigma is equal to 1.4, writing in the form of an equation and solving this for equations of two variables, I get mu is equal to 50 and sigma is equal to 10. This is almost similar to the previous example, except that here both the conditions are less than. That is, in an examination, 7% of students score less than 35% of marks and 89% of students score less than 60% of marks. Again, find the mean and the standard deviation. So I'll take the condition P of x less than 35 is 0.07 and P of x less than 60 is 0.89. The same equation, that is standard normal variate, z is equal to x minus mu upon sigma. Take for x is equal to 35, z is equal to z1, and for x is equal to 60, take z is equal to z2. So I have p of z less than z1 is equal to 0.07 and p of z less than z2 is equal to 0.89. Now since both the conditions are less than z1 and z2, I'll have the curve as the same here. This will be the region. So for both, I'll have 0.5 plus phi of z1 is equal to 0.07 and 0.5 plus phi of z2 is equal to 0.89. So I get phi of z1 is equal to minus 0.43 and phi of z2 is equal to 0.39. Comparing with the given values, I get z1 is equal to minus 1.4757 and z2 is equal to 1.2263. Using these in the standard normal variate equation and solving, I get mu is equal to 48.65 and sigma is equal to 9.25.